Hello, it's Mr. Reeve here, and I'm going to make a video today on using flip-flops. I'm going to talk about what the clear preset clock pins do, and then how to use flip-flops to make a counter. I'm going to do all my demonstrations in MMLogic. It's an older program, but it actually works pretty efficiently for what we need. Okay, so here are a few of the flip-flop circuits I'm going to talk about. The first one was just explaining simple RS flip-flop. You can see that the RS flip-flop has Q and a not Q, so here's our outputs, and here's our inputs of S, set, and reset is the R. When we start, we should always flick 1 to high to give it an initial value. You can see that if you start, the LEDs kind of are in a no state, meaning it's not determined. If you actually build a circuit, it actually will show you something, but I think what that's trying to tell you is that it might be random. Either the Q could be on or the not Q could be on. So it's always best with a flip-flop to start by giving it some kind of initial state. Now we can see the way there's no clock on this RS flip-flop, so in its remembering state, both the inputs are 0. As soon as one of them goes to high, the effect is immediate. If you set R to high, not Q goes on. If you set S to high, then Q goes on. If you set them both to high, that's the forbidden state. And again, we get this scenario where we have both LEDs kind of half on, which is just telling us that this is a not predictable state. Okay, so let's take a look at adding a clear and a preset, I guess. So this state here. So this is just the same circuit we just had, the RS flip-flop with the clear and preset. What the clear does is the clear will always, so when we start again, oh yeah, I should also make note here that these pins here are not clear and not preset. So in order for them clear to be on, it actually has to be, in order for clear to be on, it actually has to be off. In order for not clear to be active, it actually has to be 1. So one of the very first things you should do when you start your circuit like this is both of these, and I put this down here, both the not preset and the not clear have to be set to high so that they're not trying to reset the outputs. What they do is they give initial value to the state. So I'll show you now. So right now they're not being used at all because they're set to 1, which causes them to be, the preset and the clear, both to be 0. Now at any time, if you click them to 0, it'll set the output. So if I click the preset to 0, it makes the Q go on. If I click the clear to 0, it makes the clear come on, and it clears the circuit. So no matter what else is going on in the circuit with the inputs in R and S, the preset and the clear always override everything. Now they have to be in a 1-1 position because they're so that they're both off in order to use the actual flip-flop. And now once they're both in the 1-1 position, so they're both off, then we can use the RS flip-flop as we did before, and it behaves just like so. But so for example, say we turn the S on, if we turn the clear on, it overrides the inputs and it turns the clear on. As soon as I turn this back off, it's going to go back off because the S is set to high. So it's very important to realize that the clear and the preset kind of override everything else that's going on with the inputs. And when we want to actually use the flip-flop as a flip-flop, we must make the clear and the presets, set them to high to turn them off. Alright, so JK flip-flop. Let's just take a look at it. JK with clock and, okay, that's a D flip-flop. So let's add the clock value. Now, a JK flip-flop and an RS flip-flop are almost identical with one difference, and that is, let's go back to the RS flip-flop for a second. If they were both on, in the RS flip-flop, if both S and R are on, this is the forbidden state, and we see the outputs kind of go to their undetermined values. Now, the only difference in a JK flip-flop is that when both the inputs are on, then the outputs just toggle back and forth. So they never go to a forbidden state, they just toggle back and forth really quickly. So this is the JK flip-flop. I did add a clock here, but I can show you what I mean. So if we start here by flicking the preset and the clear to high so that we turn them off, and you'll see that the J acts just like, oops, sorry. For now, let me just turn the clock on so I can just ignore the clock. I'll just leave it on. If you turn the J on, the Q comes on. If you turn the K on, hold on one second. Let's just try that again. Hold on while I think for a second. Okay. Well, I can't demonstrate it exactly right now, but that is the difference between the RS flip-flop and the JK flip-flop. Okay, so now let's go to a clocked. When you have a clocked, essentially what the clock does is it only lets J and K go live when the clock is up. So again, we turn the preset and clear on. Because I turned the clear off last, that's why we're at not Q. If we do that in the other order, turn the clear off, and then that means that it's going to be preset to Q is going to be on. So it depends which order I turn those both to high. But now that they're both to high, the inputs are live. What we can do here is, this seems to be in some flip-flops, so this seems to be only active when the clock goes from 0 to 1. But let me just demonstrate then by flicking the clock on and off. If the J is up when the clock goes on and off, then the Q will come on. If the K is up when the clock goes on and on, then not Q will come on. If they're both up when the clock comes on, then all it does is toggle back and forth. And so this is what I was talking about, the difference between the RS flip-flop and the JK flip-flop. Whereas if this was an RS flip-flop, when both J and R and S were on and the clock would go high, then it would go to an undetermined forbidden state. So this is actually kind of nice that it toggles back and forth, because then we have a toggle flip-flop that just toggles back and forth when the clock goes up and down. Okay, so now let's talk about a D flip-flop. The D flip-flop, the way that it works, and this is a clocked D flip-flop. Let me show you if you're going to use MM Logic. We have a data latch. So the way that it works is, again, starts in the forbidden state, so unknown state really. And whenever the clock goes high, it just takes the value of whatever the D is on the D. So if clock is 1, then the Q comes on. If D is 1, Q comes on. If the D is 0 when the clock comes on, then the not Q comes on. Now, this straight up just as a D flip-flop, actually when the clock is on, the outputs are live. So whatever I change D to, it actually changes it right now. And so really with the D flip-flop then, it actually only records the value and saves the state when the clock goes from high to low. So because I can do whatever when the clock is on, but as soon as the clock goes low, that's what it remembers, and now I can do whatever I want to D, and it doesn't have any effect. So kind of remember, it's about getting to know, the flip-flops. This one's very important, that whatever it is when it goes from 1 to 0, that's what it is, that's what it will remember. Now let's add the clock, clear, and preset lines to the D flip-flop. Again, the preset, if it's on last, or on at 0, then that's what it will remember, and if the clear is on, then it'll set Q to be high, and if the not clear is the last one to be turned off, then not Q will be on. So if I turn them off in this order, right now clear is on, so I turn them both off. Now the flip-flop is live. Now let's take a look at the flip-flop. And it actually pretty much just works the same way. When the clock is high, the output is live, and as soon as the clock is low, then the inputs are ignored. So that was just, we have to always remember though that the very first thing we do, and we can actually set these initial values to be 1, but it is kind of nice to give the flip-flop an initial state if they start with 0, and then we turn them to high. Now let me just talk about let me talk about edge triggered flip-flops. So one of the properties here is edge triggered. If I turn this on, we're going to see one difference. Now you just saw when I set the presets and the clear off, when the clock was on, I could do whatever I wanted to the input. So that was before it was edge triggered. Now I changed the chip so that it's edge triggered, and it actually only will record the value when the clock goes from low to high. So this is handy. So now when the clock goes up from 0 to 1, then it looks at the value of D, and that's what it sets the output to for good until the clock goes to 0 and then back to 1 again. So if I set this to 0, change the clock low to high, and then low again, or let me just put it at high, I can do whatever I want here, because it only changes the output when the clock goes low to high, and that's what we call edge triggered. Now this is actually good when we're going to use this as a counter, because if it's not edge trigger, then it just kind of it counts really, really quickly through all the states. Whereas if we make it edge triggered, then it'll only count when the clock goes from low to high. So let me just demonstrate that again. I want a 1, I cycle the clock from low to high. I want a 0, cycle the clock to low to high. If I leave the clock up, the D value doesn't make any difference. Let me just change that value quickly to non-edge triggered and show you the difference. So I turn the presets off. I flick D, I change the clock, but notice now that the input is actually live, and whatever I change the D to, it takes effect until the clock goes off, and then it doesn't have any effect. So that's what edge triggered is. So now let's take a look at a couple of circuits, and our goal here is to make a counter. So what we have here is we have a D flip-flop with clear, a preset, and a clock with non-edge triggered. So essentially what we're going to do when we make a counter now is we're going to link a bunch of D flip-flops, and this is the 74LS74 chip, and it is edge triggered, and it does have all of these. It has a clock, a preset, and a clear, a D line, a Q, and a not Q. So we should be able to wire a 7474 up just like this, and hopefully it should work. So I have the only difference between this circuit here and this circuit here is one is edge triggered and the other is not, and I want to show you what the difference is. So if I go ahead and simulate, oh whoops, okay, pause, play, okay, turn the preset and the clear off. Now how does this work? Let's just take a look at it. The clock comes in and the D line isn't a switch, so this is new. What the D line is it's going to be not Q. So the D line will come up, not Q will come up to the D, and Q will be our output. So let's see what happens. If it's not edge triggered, then as soon as I make the clock high, it just toggles back and forth. And this is because the D value is constantly toggling, because if D is off, then if D is on, then not Q will go off. But that makes D off. When D is off, not Q comes on. And then that makes D on. And then that means that not Q is off. And it just keeps flicking. So as long as that clock is on, it just keeps toggling back and forth between the states. Kind of useful. Useless. Useful, useless. It could be useful, but for making a counter, we don't want that. So the only difference in this circuit down here is we've made it edge triggered. And so let's set the clear in the presets. The only time that this will change the outputs again is when the clock goes from 0 to 1, and this is much better because now I only toggle when the clock goes from 0 to 1, it toggles. And so it's still toggling just like before, because if we take a look at what's going on right now, Q is on, which means not Q is off, which means that D is off. Okay, now if D is off, if this was live, then Q would go off, but it's not live, it's edge triggered. So when I click this clock from to high back to low again, D was 0, and now that makes Q go to 0. But if Q is 0, not Q is on. It means that now D is on. Okay, but it's not going to have an effect on Q yet until the clock goes to 1 to 0 again, and then it toggles it. So essentially what this does is it just toggles. Every time the clock pulses, it toggles Q to go on and off. And this has an interesting effect that it actually, Q is actually half the frequency of the clock. So, because it takes 2 clock pulses for the Q to go on and off. So it's exactly half of whatever my frequency of the clock is, which is kind of interesting. Now, let me demonstrate what the clear and the presets do right now. So, in whatever state is going on, you can always, if you flick the preset to on, which because it's not preset, you have to turn it off, then it makes the Q come on. So no matter what state the thing is in, and then clear does the exact opposite. If I make clear come on, then it clears it. Now we don't want them both on. That makes it the forbidden state, because what it's trying to do is it's trying to make immediately, it's trying to make Q and not Q both come on, and that you can't do that. Alright, now let's link a bunch of these together. So we can link them together in 2 ways. If we link them together in this way, then we get a down counter. And if we link them together in a slightly different way, we have the not Q come around to D, but also into the clock of the next one. If we link them this way, we get an up counter. So let me just demonstrate both of them. We'll start with the down counter. So if I flick the preset and clear lines, so now the state is usable. As I pulse this clock, they all come on, and then if I keep pulsing it, it's counting down. So that was a value of, if that was 1s, 2s, and 4s, that was a value of 7. And if it's 1s, 2s, and 4s, so it's a little backwards, because usually we have 1s, 2s, and 4s. But it's just the way I have it set up. So it's 1s, 2s, and 4s. Then this is a value of 6. And if I pulse it again, right, we get a value of 4 plus 1, which is 5. Pulse it again, we get a value of just 4. And then we get a value of 3, then 2, then 1, then 0, and then we go back to the value of 7. Right? So 4 plus 2 plus 1. Now, the up counter works very, very similar, but we count up instead. So we start by turning the preset and clear off, and then let's just pulse. So we count by 1, 2, oops, I clicked the clock a couple times there. So now we're at 3, then we're at 4, 5, 6, 7, and back to 0. Now let me demonstrate how the clear works. So say we're counting up, and we're at a value here. I can clear it at any time, and go back to 0. Same thing, if I do a preset at any time, all of them come on, because all the presets are linked to the switch. but typically when we're using these, we set the not clear line to high and the not preset line to high to turn the clear and the presets off. If you want kind of more details of what's going on here, remember these all have to be edge triggered, otherwise the thing just starts counting up or counting down as quick as it can. And if you want kind of to see how this is working, just follow the lines as you make the switch. So let's clear this. Essentially what's going to happen here is this when I click the clock from 1 to 0, it makes Q come on and not Q go off. But when I click it again, not Q comes on. Now when not Q comes on, Q goes off here, but it causes, because this is the same circuit, it causes a clock pulse. So essentially the clock pulse of the second one is coming from Q, which we know is going on and off half as many times as the clock. And so if I do this again, it has no effect right now on the second one, because it's just the clock is going off on the second one, but the clock is going caused Q to go on here. But if I pulse it again, then Q actually, not Q comes on, which makes this one go off, and it actually makes the first one go off. And so it's kind of got a ripple effect, and that's why it's also called a ripple counter. Both of these, so you could have a up ripple counter or a down ripple counter. And now on these, let me just show you that the properties of these. It's a data latch, so D flip-flop. It's got preset and clear on and the edge trigger on. I hope that helps you understand how some flip-flops work with the clear, the clock, the preset lines, and also how we use a D flip-flop to make an up counter and a down counter.